Hello students, myself Manjunath. So today I'll be teaching a topic on trigonometry. It is class 10 topic. Trigonometry. Here tri stands for 3, gono stands for angle, and metry stands for measurement. Now students, why we need to study about trigonometry? It is basically about to know the angles and side measure of a triangle. Say for example, we consider a triangle. It is always most important that it is defined in a right angle triangle. So the triangle A B C, so it is right angled at B. So this triangle has 3 sides. The sides are AB, BC and CA, and it also has 3 angles: angle A, angle B and angle C. So the sides are AB, BC, CA, and angles are angle A, angle B and angle C. Angle A, angle B and angle C. And one more important concept you need to remember here is, students, the important concept is this trigonometry is always defined in a right angle triangle. This is most important, students. So first, why we need to study about trigonometry? What are the applications of trigonometry? The applications of trigonometry is, it is used to, suppose you know that you have to find the measure of, assume this is your Qutub Minar and you have to find the measure of its height, okay. This can be done with the help of, if you just, I already told you, it is with respect to the relations between sides and angles of a triangle. It is always defined in a right angled triangle. Right angled triangle, students. So it is always defined in a right angle triangle. Suppose this is the height of your, we can call it as EF is the height of Qutub Minar, and you know that FG is its shadow. If we know the elevation, if we know the height, the distance of the, if we can measure the distance of the shadow of the Qutub Minar, and also if we view from here the elevation, the angle of elevation, if we know, if we also know the angle of elevation, and if we know the angle of elevation, say for example angle of elevation, here it is, assume this is the height is of the shadow is 50 meters and angle of elevation is 30 degree, then we can find the height of the Qutub Minar with respect to various trigonometric relations. See, trigonometric relations, and also we need to it is just an estimation. So usually what will be given is, you will be having the height of the from the base to, from this point, from where you are viewing, it is 30 and this is your 50, and also we can find what is the height of EF. That can be done by relation. We will be studying various relations of 6 trigonometric functions. Okay, this is one of the applications I am telling you, students. This is one of the applications. So before we discuss about, so here we'll say the applications. Suppose height, what are the parameters? We know height of, to find the height of Eiffel Tower, we know the parameters, the distance or the length of the shadow, and here we also have one more parameter is angle or elevation angle. Elevation angle we know. Elevation angle with respect to those angle of elevation, that is your theta angle, and one side we can find the height of the Eiffel Tower, or you can also take it as Qutub Minar, with anything. Is it not wonderful, students? Because you are not, suppose you have to find the height of the Eiffel Tower or Qutub Minar, then you can't measure with the scale. That is quite ridiculous. The simple technique is, just by knowing the angle of elevation cast, we can easily find the height of the Eiffel Tower. Just if we can measure the simple distance or the length of the shadow cast with respect to the, like when the sun falls any object, it casts a shadow, then we can easily measure with scale or measuring tape the distance or length of the shadow. And the angle of elevation also with what we are viewing. This is, suppose a human being is standing here, with what angle of tilt is observing. So that with that we can find the angle and we know the length. Is it not wonderful? Just by knowing one length, one side measurement and one angle measurement, we can easily calculate, find the height of Eiffel Tower or Qutub Minar. Is it not wonderful, student? Is it not something to be surprised? Because we easily found out the height. So for that, and I'll come with the various trigonometric functions. Before that, I'll want to tell you one more important other applications. Other applications are, say for example, you have one more, I'll take one more easy example. It is, you have lamp post. This is M. Okay, this is the river, length of the river. And also with that again we have, if we know this is the angle theta, if we know any one parameter, the length or the angle, we can also find the height. Is it not wonderful, student? Look at the beauty of trigonometry. And one more easy example is also, if we have, there are various examples we have. Suppose it is the two parachutes are there, it is going at height. Okay, this is parachute A and parachute B, you assume it is at different height. Okay, if we view from a single point like this, various relations, this particular distance A, this particular distance, this and this will be equal, and this will be equal. This is A, this is your C, then this is your D, and this is E. We can say that the important parameter DE will be equal to AB and BE will be equal to AD. If we know angle of elevation, that is simple angle of elevation from here where we are observing here, these two angles will be 90 degree. We can also find the various relations. If we know two parameters, the distance, we can also find the height at which the parachute is placed. See, this is the beauty of trigonometry, students. Now we'll get into the some of the important relations. So we have just, I'll take the simplest example which I gave in the initial. Suppose we have to find the height of the Eiffel Tower. If we know the, we'll take this length itself, we'll try to solve this. This is 50 meters and this is the 30 degrees, and we have to find the height of the hypotenuse. How do we find? We have 6 trigonometric relations: sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. Sine theta is equal to opposite by hypotenuse. Cos theta is equal to adjacent by hypotenuse. Tan theta is equal to opposite by adjacent. Cosecant theta is inverse of sine theta, reciprocal of sine theta, so that will be h by O. H stands for hypotenuse, O stands for opposite, A stands for adjacent. So secant theta is h by A and cot theta is A by O. Now, how to know which side is opposite, hypotenuse or adjacent? For that, this I already told you, trigonometry is only holds good when it is defined in a right angle triangle. So this angle, angle F, is always equal to 90 degrees. If this is 90, this is 30, then can you tell me the measure of angle E, students? That is by angle sum property, angle E plus angle F plus angle G is equal to 180. So 90 plus 30 plus X is equal to, plus angle X is equal to 180. Then we can find X as 90 plus 30 is 120. 120 plus X is 180. X will be 60 degree. That is not the point here. So if we have only one measure, okay, we can easily find the height. So how we'll proceed? I just told you, I was just trying to refresh your angle sum property of triangle, students. So now we have what, first let us try to understand what are the sides, how we denote it here. Opposites, which is the opposite side, which is your adjacent side, and which is your hypotenuse side. Now this is 90 degrees the reference base. The side opposite to 90 degrees always the hypotenuse. So EG is the hypotenuse. It is the longest side, hypotenuse. And the side which is opposite to, suppose we can consider either angle E or angle G. If we consider angle G, because we know angle G, angle opposite to 30 degree, here angle G will be always opposite, because it is opposite to the given known angle. So this side will be called as opposite. Then what is the remaining, students? Which is adjacent, which is adjacent to the angle given. So h by A. So the angle opposite to 90 degrees is called hypotenuse. The angle opposite to the given angle is called opposite, and the remaining base side is called adjacent. Then if we just substitute, we'll try to substitute here. So that will be sine theta is, so we can directly say sine 30. Sine 30 will be O by H will be, this is O. O we can find, and H is, H also we don't know. So we cannot use this relation, students. Then we have to go with the next adjacent. Adjacent also we don't know, and hypotenuse also. Adjacent we know, which is adjacent is, we have adjacent as 50 upon hypotenuse we don't know, but we also know cos of 30, and we can easily find the hypotenuse. But again, it's a process, so you should know how to judge which side, which trigonometric ratio you have to find to directly minimize your steps to find the, we want opposite side. So this will be tan of 30, if we substitute, is equal to O by A is 50. Then when we solve that, directly we'll get O is equal to 50 tan 30. I'll tell you, we'll discuss these things in detail. So this is the required length of the Eiffel Tower or Qutub Minar. Is it not wonderful, students? It is so beautiful. So only thing is, you have to just, I gave a simple concept, how it is defined and how we can find the relations Okay, so you can also find various, there is trigonometric table to find the various relations cos theta, tan theta, and these six trigonometric relations also. Okay, so that's how you find the height of the Eiffel Tower. Is it not wonderful, student? Just by knowing the height or the length of the shadow, and also the angle of elevation, only one parameter, and other parameter, two parameters, we can easily find the height of Eiffel Tower. It is wonderful because the application is awesome. It makes our calculations very simple. Just by knowing the trigonometric relations, we are able to find the height of the Eiffel Tower. Okay, students? Okay.